Are you ready to put everything we've talked about in this section? This has only been one section somehow. Are you ready to put everything together? Well, here we go. We got two messier examples. And the most important thing when you're doing these longer problems is to do it step by step and write things out. So this first problem wants us to take the derivative of one function times another function. Call this g and this f. Flip the order of what I said. And yeah, we'll use the product rule. Now, notice that to find f prime, we need the chain rule. To find g prime, we need the chain rule. So we're going to have two chain rules before we even get started with the product rule. Over here, let's say, okay, f of u needs to be something, and u needs to be something. That's how we can set up the chain rule. U is the inside function. What's the inside function here? 3x. What is being done to 3x? It's getting exponentiated. You can always double check that if you put this in, you should get the original f. U is 3x, so we get e to the 3x, just like we wanted. We do this. Okay, so now we know that dy, you could also write it as df, du. That'd be dx is what we want. We want f prime. You could write that as df dx, the derivative of f with respect to x. That's going to be the derivative of f with respect to u times the derivative of u with respect to x. What's the derivative of f with respect to u? Itself. That's the nice thing about exponentials. What's the derivative of u with respect to x? Just 3. We get 3 times e to the u, and u is 3x. Again, we could have also taken this derivative by saying, take the derivative of the exponential function, leave the inside alone, and then multiply by the derivative of that inside, and you'll get the same answer. This is our f prime right here. Very important to make sure it's all in terms of the original variable. We'll do the same thing with g. We need a g of u, and we need a u over here. What's our u over here? What's our inside function here? It'll be 5x plus 7. What are we doing to 5x plus 7? We're taking the natural log. We'll double check our answer and say, okay, if we put this in for u, do we have g? Natural log of 5x plus 7? Yep, we do. So the derivative of g with respect to x is going to be the derivative of g with respect to u times the derivative of u with respect to x, just the chain rule. Derivative of g with respect to u, the derivative of the natural log function is the reciprocal. Times the derivative of u with respect to x, the derivative of a line is its slope, which is 5. Put everything in terms of our original variable, and we'll get 5 divided by u, which is 5x plus 7. We cannot cancel here, because you can only cancel if there's a common factor. We cannot factor 5 out of the whole denominator. This is our g prime. Now we can use the product rule. So the derivative of f times g is f prime g plus fg prime. Just plug in and simplify now. F prime, we said, was 3 times e to the 3x. G, we said, was the natural log of 5x plus 7. Plus f, which is e to the 3x, times g prime, which is 5 divided by 5x plus 7. And again, most of the time, this is going to be enough. If we really want to, we could factor some more. What do both terms have in common? Well, they both have an e to the 3x in them. We'll factor out an e to the 3x. The first term is left with 3 natural log of 5x plus 7. Second term is left with 5 divided by 5x plus 7. And this will be our final answer. If you can get here, that's fantastic. If you can get here and here, that's most of the points. And if you can get to here, that's probably going to be all the points. Let me know if you have any questions about this. That's how we can take the derivative of one messy function. You want to do some more? Let's go. This one is also really messy. Look at all the pieces we have. We have a chain rule situation. Here is our inside function. And then we're raising that to the 4th power. I got this from the book. Oh my gosh, book. Short answer, I'm not going to give you something like this, but you want to come along for the ride? Let's go. Okay. So, and then we're going to need to find the derivative of u because chain rule. So z is some function being applied to u, and u is that 3t cubed over e to the t times t minus 1. Z is going to be what's happening to the u. U is getting raised to the 4th power. So the derivative of u with respect to t is going to be the derivative of z with respect to t is the derivative of z with respect to u times the derivative of u with respect to t. This derivative. Of course, finding this derivative is going to be a little involved. Because, look, we have an f, we have a g, and even g. To find the derivative of g, we also need the product rule. So we got the chain rule, and inside the chain rule, we got the quotient rule, and inside the quotient rule, we got the product rule. I'm not going to make you do this, but here's some practice. I didn't realize how messy this was when I took it from the book, because I do adapt. Check out this citation. I do adapt my notes when I create them from the textbook, and I throw out things and I put things in. You can compare them if you want. This is an extra spicy. It's like you're cooking and you accidentally, you weren't looking, and your roommate just pours a bunch of habanero peppers or Sichuan peppers. I don't know what kind of, ghost peppers. You don't notice until you start eating it. Okay. Let's stop complaining and just get to work. So, the derivative of u, let's go off to the side. We're going to need to use the quotient rule. Low d high minus high d low. Square the bottom, and away we go. And of course, we're going to have to pause here because we don't know what g prime is. So we're going to go off to the side again and say, okay, what's the derivative of g? Well, that'll be the derivative of the first thing times the original second plus the original first thing times the derivative of the second. This is just the line. The slope of a line is its slope. That's a silly thing to say, but it's true. The derivative of a line is its slope, which is 1. The derivative of an exponential function is itself. So we have g prime. Let's simplify, and then we'll just start going through it. So we can factor out an e to the t from both things. When we factor it out from the first thing, we're left with a t minus 1. When we factor it out from the second thing, we're left with a 1. Ooh, this is really nice. Look at this. Minus 1 plus 1, those cancel. G prime is really easy. It's really nice looking. Wow. What a nice problem. Look how nice G prime is. All right. So when we're doing U prime, that's G, which is e to the t times t minus 1 times f prime. Use the power rule. That's going to be 9t squared minus f, 3t cubed, times g prime, which we said was t times e to the t. Oh, always right off the screen a little bit. That's all divided by g squared, e to the t times t minus 1, like so. We could simplify this. Again, I'm not going to give you a problem this messy, okay? What is the derivative of z with respect to u? Use the power rule. It's 4u cubed. What's the derivative of u with respect to t? We just found it over here. We could simplify. At this point, I don't think it's worth it. Just going to write it all out. T minus 1, 9t squared, minus 3t cubed, times t e to the t, all over e to the t times t minus 1 squared. The last thing that's left is, what is u? U is all this. You have to replace it. So we're going to get 4 times u cubed, and u is 3t cubed, for e to the t times t minus 1, times all this stuff, e to the t, t minus 1, 9t squared, minus 3t cubed times t e to the t, all over e to the t times t minus 1 squared, and then simplify. That's just going to show you how you approach these problems. Not going to give you something this messy. This is not going to pop up in our applications, but it does show the framework. There's a lot of steps. You just start with the first step. Okay, we need to use the chain rule. What's our inside function? Set up the chain rule and said, oh, I don't know how to find this. So you go to the side and find it. And then while finding it, you say, well, I don't know how to find this. So you go to the side and find that. And then you eventually start filling things in. Is how you approach these more difficult problems. Again, I'll say it for the 50th time. You don't need to do this example. Even this example over here is harder than anything I'm going to ask you to do. But it's good practice to see harder examples, and I don't want to stay away from harder examples, because if I only ever do the simpler examples, then you don't have as much to learn from, I think. So that's why I included some of these messier ones, even though they're not something I'm going to ask you to do. They may pop up on homework, but that's more of for practice. Let me know if you have any questions about this or concerns, and have a good rest of your evening. Hope you are ready for a nicer video. The next one's nicer. Bye-bye.